Today is Wednesday, May 11th, and this is William Michael of the Classical Liberal Arts Academy. I'd like to do something a little different in this talk. Usually, I publish talks in which I answer questions or address topics that have been requested by friends or by students and parents in the Classical Liberal Arts Academy. And they're usually questions about the subjects that I've gained expertise in teaching over the years. But in this talk, I'd like to do something a little different. Rather than talk about something that I've become an expert in, I'd like to simply share some questions and thoughts that I have on a subject that I haven't really had the opportunity to study as deeply and carefully as I would like to, and as I intend to in the future. I'd like to share some thoughts with you and invite you to study and discuss these things with me as I seek to gain a better understanding of what I consider to be a very important question or set of questions. The title of the video, the title of this talk is, Are Atoms Real? Are atoms real? Or do atoms really exist? Do atoms really exist? And if I were to post that question on social media, the comments would be flooded with arrogant scoffers who attack me personally and call me names for being ignorant and absurd. They'd call me all kinds of nasty things because I ask the question whether or not atoms really exist. And yet, when I ask this question, before God, I can swear that I'm not being contentious or silly. I'm not trying to just stir up some arguments or get attention. This is a serious question that I ask. And I think that as we talk through it a little bit, I can convince you that it's not a joke, it's a serious question. Whether atoms really exist. Now, I grew up in a public school. I went to public schools as a kid, had public school science classes where teachers showed us illustrations and diagrams in chemistry classes, science classes. They showed us diagrams of molecules and atoms with protons, neutrons, and electrons. They explained to us all these things. We learned all of this vocabulary. We learned to draw these things ourselves, and we memorized the definitions. We memorized the rules of chemistry, and we repeated all of this information on our exams for our grades in these classes. We proved that we could study and understand all of the content of our chemistry lessons. We proved that we could answer the questions about what an atom is, what all these different particles related to atoms are, how atoms are joined together, what causes atoms to be attracted to one another or to be repelled from one another. We learned all of these things, memorized these things, and repeated them in our science classes for grades. I went on to college, and in college I majored in biology, studying as a pre-med student. I went on to in college and majored in biology, and in college science classes we do the same thing, only in a deeper level and spread out across more subjects. So in college science classes we go ahead with biology studies and into chemistry, into organic chemistry and physics. And we go through these studies in more detail than we did in our high school classes. And yet, even though we're going into more detail, we're reviewing many of the things that we were introduced to in high school, and we're going further into more detail, but we're still not getting any proof, any demonstration that these things are actually true. We're not getting any evidence. We're not being shown any demonstrations that these things are true. We're not being shown that these things really exist. We're never shown an image, a picture of a molecule. We're never shown a picture of an atom or a proton, neutron, electron. We're never shown any actual, demonstrable, material evidence for any of these things. We simply continue memorizing vocabulary, memorizing definitions, copying illustrations and diagrams, and so on. And we continue in these studies. And as we continue, even through a college education, there's no demonstration, there's no first-hand evidence. We simply receive all of this information and we memorize and repeat it in the same way that we memorize and repeat the questions of the catechism. And what I ask is this really science that we're being taught? Or is something else going on in the name of science, and we're being told that we're doing something that we're not actually doing? We're being told that we're no longer just reading a philosopher and repeating what he says. We're no longer reading the Bible and simply accepting these things by faith. We're being told that as scientists, we're using our own senses to observe and investigate and experiment, to search out the truth, and not to simply trust in the sayings of others or in the authority of different institutions on earth. We're seeking the truth directly through the scientific method as we study the natural sciences. But we don't actually do that. We're not actually doing that. We're not actually investigating anything. We're not experimenting. Every experiment that we perform is staged and prepared. We're not going out into the world and asking questions and seeking answers. We're not conducting new experiments that seek to answer questions we have. We're simply going through the instructions of prepared, packaged experiments and memorizing things that are contained in textbooks that tell us what we're to think about the natural world. And yet, we're being told that we're not doing that. We're being told that we're not simply accepting information that we haven't seen for ourselves. We're being told that we're not just believing what someone else says. We're not simply accepting someone else's testimony. We're investigating, experimenting, observing for ourselves through the natural sciences. But we're not doing that. We never do that. I went through the first 3 years of a college biology degree program and worked in a chemistry lab. And never was I given any demonstration by which the truth of these things might be known in the way that we were told we were seeking this knowledge. I was simply told what's true, and I was tested for my ability to repeat it. And so, At the end of these studies, I started to see that what I was taught science is, science really is not. I was not learning about the natural world, which I was very interested in as a Christian because I saw the world as God's creation. I was not being given the opportunity to learn about the natural world through careful observation and experimentation. I was being told to think about the natural world in a certain way with no demonstration for why I should do so. The motivation to learn these things and repeat these things was all driven or all founded in my hope for good grades, my hope to go to medical school, my hope to have a successful professional career. That was my motivation, to memorize all the lines and repeat everything perfectly. And I was a Dean's List pre-med student. But what we were doing in the name of science was not what the science books say that we're doing. We were simply being indoctrinated and told how to think about the natural world. We weren't observing, we weren't investigating, we weren't experimenting. We were reciting in the same way that I would recite the questions of the catechism. And as a senior in college, I realized that I was on a dead end and that I was getting into trouble. Subjects that I should be studying, I wasn't studying. Topics I should be gaining knowledge in, I wasn't gaining knowledge. Instead, I was simply memorizing a worldview that was being taught to me in the name of modern science with no evidence for the truth of that worldview. And that worldview, most frighteningly, that worldview was actually becoming my worldview, and I knew no other. It was all that I had ever been taught, all that I had ever known. And so I began to study the classics. I began to study classical philosophy, classical natural philosophy, and so on. And that was how my interest in classical studies began. But I'm interested in this talk in getting back to modern science, because I have questions about modern science, and I know they'll be scoffed at by people who, like me, have simply memorized what to say. And imagine that somewhere, someone else has actually investigated these things and observed these things and conducted these experiments. But I have no evidence that that's true. And when I ask for it, like I said, I'm scoffed at. One is treated like he's crazy if he asks for evidence that these things are actually true. And yet, the whole point of modern science is supposed to be that all things may be demonstrated and visible to all men. Well, I say baloney. I don't believe that's what science is doing at all. And that's why I continue to ask the question whether atoms really exist. And I'd like to talk a little bit about the history of the sciences that I do know to show why I think this question is much more important than we realize. Whether or not atoms really exist is a serious question. Like I said, I'm not being contentious. do atoms really exist? And so first we have to ask, what are atoms? What are atoms? And the simplest definition of an atom is the smallest indivisible part of which a thing is composed. The smallest indivisible part of which a thing is composed. I think that's a good definition of an atom, but it may not be. Like I said, this is not my expertise. I have questions that I'd like to ask and study and discuss. But I'm pretty confident that an atom would be defined as the smallest or simplest, maybe simplest is a better word than smallest, the simplest indivisible part of any physical body. The problem with this idea of the atom is that this idea that material things are composed of invisible, small, simple particles is not an idea that was developed through modern experimentation. In fact, the idea or the philosophy of the atom is an ancient philosophical idea. It's an idea that philosophers like Plato and Aristotle heard and rejected. The idea that the natural world is composed of atoms is a philosophy that the great philosophers tried and found wanting, and it was rejected. It's not that the ancient philosophers were ignorant and couldn't comprehend this idea. The idea is actually very simple. It was an idea, however, that they rejected. The primary reason why they rejected this idea was not that the idea itself could be proven false, because it's impossible, because the atom is invisible. We can't prove it true or false. And it's just as important, for the sake of honesty, to realize that the scientist cannot prove the existence of the atom any more than we can prove that it doesn't exist. And so the answer has to be found somewhere else. The truth of this idea of the atom has to be pursued somewhere else. We need some creative line of argument by which we can reason to prove or disprove the truth of the atom. And for the ancient philosophers, that proof came through other questions. Questions of whether or not there was an end for all natural things. Whether all natural things have some purpose or function in their essence, built into them by nature. Or whether they were simply a collection of particles that was assembled by chance. And Aristotle rejected any such ideas and argued that nature does exist for an end, and natural bodies, even down to their parts, all have functions that they're designed to perform. We can see this reality with our own eyes by looking at our own bodies. We can see that we're made to do certain things, and other human beings have those same faculties and parts, organs, etc., to do those same human things. Cows have different parts, different organs to do different things. Trees have different parts, different organs to do different things. We can see all of the various kinds of living things, and we can see that they exist according to groups and classes and species, not as a bunch of chance individuals, but as similar species and classes of things. that live the same way, have the same parts, perform the same functions, and so on. This idea that the world is simply a collection of atoms is easy to disprove through reasoning. And that's why the ancient philosophy of atomism was rejected. And rather than atomism, Aristotle's natural philosophy was accepted by all of the wise men and remained dominant for over 1900 years before men brought it into question and proposed, or revived, I should say, revived this old idea of atomism, going back again and trying to establish the atom as the foundation of natural philosophy. And the truth of this was to be demonstrated, according to Francis Bacon, who is considered the father of the scientific method. This question of the atom was to be settled by an experimental investigation that would tell us the truth. And great effort was invested after Francis Bacon published his writings on science and on the development of the new method, that is the scientific method, rather than ancient philosophical reasoning. Francis Bacon explained that instruments would multiply the powers of our senses and allow us to see, hear, feel, smell, and so on, more than we can with our naked senses. And so there was a great emphasis, as there remains today, on the development of improved instruments. And as these instruments developed, and as a few wealthy nations that had the resources to develop and produce these instruments increased over time, our ability to look into the natural world also increased. So we have the invention of telescopes and microscopes, just to get started, and then many other different instruments to enable us to study the natural world in a way that's far more detailed and subtle than we can by our naked senses. And as men began to investigate with the use of microscopes and telescopes, new theories began to be proposed that contradicted the old theories. But like I said, they never came with demonstration. Contradictions were proposed, opposing ideas were proposed, established ancient ideas were thrown away as if they'd been disproven, as if they'd been proven to actually be impossible in light of the data. But that was never actually so. The ancient teachings were never disproven. Alternatives were proposed, and scientists worked to show that the alternatives that they proposed appeared to agree with what could be seen and heard and so on. These alternative views were promoted not because they were proven to be necessary, but because they were shown to be possible. The alternative teachings about the natural world were embraced and promoted not because they were demonstrated, not because they were shown to be necessary, but because they were shown to appear possible. And this idea of embracing scientific theories because they appear to be possible is unreasonable. What it shows is a predisposition to abandon the ancient views. It shows an eagerness, a readiness to abandon ancient explanations for things. Explanations that were based on the reasonings of great philosophers, the authority of divine revelation, and so on. And when alternatives were proposed, men were ready to jump on these bandwagons, as it were, if it could be shown that they were even possible. That's how desperate men were to abandon the teachings of the ancients and of the authorities. So, for example, when Galileo, looking through his high-tech new telescope, wished to propose an alternative theory about the movement of celestial bodies, he did so because it appeared that his theory could be in agreement with what he could observe. He did not prove that the ancient theory was false. He did not prove that his theory was true, but he was eager to promote this theory for some strange reason. For some strange reason, he was zealous to promote this heliocentric idea. And we have to ask the question, why would he be so zealous to propose this new idea? It wasn't necessary, it wasn't demonstrated, and yet he was zealous to run to print this new model or theory of the universe. The Catholic Church forbid him to do so because he could not demonstrate that it was true. The Catholic Church permitted him to conduct this experiment, to carry out these investigations, but the Catholic Church told Galileo that he shouldn't publish these ideas. He shouldn't make these ideas known to the public until he had first provided demonstrative evidence, which the scientific method was supposed to be so concerned with. And yet, before any demonstrative evidence was ever established, Galileo chose to disobey the church and run to print, and he published his ideas. For doing this, Galileo got himself excommunicated. And there were reasons why the church was hesitant. First, it's very clear that the heliocentric theory does not agree with statements in sacred scripture that describe the celestial bodies. It's very clear that there's no suggestion in sacred scripture that the earth moves around the sun, but rather, on the contrary, there are many statements in sacred scripture that suggest that the sun moves around the earth. And therefore, proposing that the earth moves around the sun was discouraged by the church because it contradicts sacred scripture. And we could say, yeah, but sacred scripture is not a science book. It's not necessarily concerned with teaching us about the mechanics of the universe. And we can say, of course, that's true. But if you're going to contradict it, You should only do so if you have demonstrative evidence. And again, the scientific method and the scientists who claim to be interested only in what can be known through experimentation and observation should have been perfectly comfortable with the challenge to show the evidence. But they didn't. Eventually, it was demonstrated that Galileo's theory could not possibly be true. And no one gives credit to the church for having made that known before. The church had no means of proving Galileo false, but the church insisted that Galileo prove his controversial ideas true before he presented them to the public. Galileo refused to provide the evidence because there was none, because his theory was actually false. Another astronomer, eventually Copernicus, revised this heliocentric theory to actually agree more with the evidence. No one talks about the fact that Galileo was wrong. Copernicus, again, for some reason, wanted to propose the idea that the Earth moved about the sun, to reject classical Aristotelian astronomy. He cleaned up the heliocentric model and brought it into closer agreement with what could be observed. Just as the world was eager to embrace the idea of atomism in the modern age, so the world was also, for some reason, eager to embrace heliocentrism. And some can say, well, that's because Copernicus proved it to be true, but that's not true. Copernicus showed that the heliocentric model is possible, but he neither showed that it's necessary, nor did he show that a geocentric model, an Earth-centered model, is impossible. He proved nothing. He simply showed that another model is possible. And this is really just common sense. We'll get to that in a minute. But this so-called scientific revolution turned out to be no scientific revolution at all. It turned out to be simply a rebellion. And of course, this was mirrored in the rebellion that was going on at the same time in and around the church with regard to religion, with the Protestant schism taking place at the same time. For some reason, there was a spirit of rebellion in that society that was eager to contradict established teachings and run in the name of science before any demonstrative evidence existed. The scientific method was not very scientific. Now what we see here is a principle where a so-called scientist proposes a model or theory. And the church has always been very kind to scientists and left them free to propose theories and to investigate them. But what we find through the history of science is an eagerness to propose some controversial theory, some radical new theory, and run with it without any demonstrative evidence. Now again, we may say, well, it's just for the sake of theory and experimentation, investigation, and so on. And that sounds nice, but what happens in modern science is the theories are presented to the common people, and they're presented to the common people with the authority of the scientists. And the actual message that's presented to the common people is, this is what the actual scientists think is true. And you can see how that's a very different message than some man who actually doesn't know what's true, proposing a theory for the sake of investigation. What happens when the ideas reach the public is something very different than when the scientist proposes the theory. And that's what has happened throughout the history of natural science. Now, this investigation continued until we get to the time of Sir Isaac Newton, where you have the rise of religious ideas that are referred to as deism. And deism, which was basically the religion of the founding fathers of America and many of the scientists of that same period, deism has an appearance of religion, talk about God, talk about Christianity, but it doesn't believe that God is intimately involved in the details of the natural world. What it believes is that God created the world and programmed laws of nature into it and set it in motion, and he leaves it to work itself out according to those laws. He's not directly involved in it. Deists don't believe in miracles. They don't believe in the idea of God's providence or presence, control of every detail of our lives, the kind of control that Jesus taught us to believe in and trust in. They teach us that God is a creator who sets the wheel in motion, programs the rules into all of the different parts of the universe, and then just lets it run its course. That's the God of deism. And therefore, the scientists at that time, who were philosophers, by the way, believed that by investigating the natural world, we could learn what these natural laws are, and that these laws would explain every physical event that takes place in the material world. There would be a material explanation for every single activity that takes place among physical things. This philosophy was made popular by Sir Isaac Newton, and it's referred to as Newtonian physics or classical mechanics. And the idea in Newtonian physics is that there's a natural or material explanation or cause for everything. Now, this was very popular and very influential because, first of all, Newton was a brilliant man, and the principles that he taught appear to be true. As men studied the principles published by Newton and then looked to the natural world, it appeared that the principles Newton taught were in fact true. It appeared that Newtonian physics was true, and it was quickly embraced. It was embraced by a generation already disposed to deism, to this idea of a distant, separate creator God who made the world programmed laws into it and set it in motion. And by learning what those laws are, we can unlock the powers of the created world, and everything will work according to those laws. We can do whatever we want with the natural world as long as we know the laws of nature. This is why in the Declaration of Independence you'll see God referred to not as the Trinity, but you'll see referred to him as nature's God. That's the God of deism. That's the God of the founding fathers. And that was the God of Isaac Newton and other scientists at the time. And so Newtonian physics became the standard. And again, they're referred to as classical mechanics. And Aristotelian physics were abandoned and rejected, removed from schools, no longer studied, and Newtonian physics replaced them in schools. And this occurred in the 17 and 1800s and continued through to modern times. Newtonian physics appeared to be true. They appeared to truly explain how the physical world works. However, in the early 1900s, instruments continued to develop, technology continued to develop, and scientists began to work at the microscopic level. Scientists began to go deeper into the study of the natural world, to see things and observe things that Newton and the Newtonian physicists never observed. And when modern scientists began to investigate the microscopic level of the natural world, they found that Newton's principles no longer work, that things are more complicated than Newton could have ever imagined. And so modern scientists will allow Newtonian physics to be taught in schools because they say, well, as far as any of these kids are concerned, or these college students, it's close enough. But it's not actually true. Newton's physics do not provide a demonstrative and accurate explanation of how the natural world operates. And the questions that arose as the microscopic world became obvious to scientists was, how do things actually work? And all sorts of phenomena were observed by scientists at the microscopic level, but because of the nature of these observations and how difficult it was to actually observe these microscopic bodies, science made a U-turn. And the scientists ceased to experiment with microscopes and laboratories, and they chose to turn instead to a different kind of experiment. And this was made famous by Albert Einstein. The scientists turned away from actual physical experiments with instruments in laboratories, and they turned instead to what are now known as thought experiments. Thought experiments, it's a fancy term that simply means imagination. Imagination. In the thought experiments, we don't conduct an actual physical experiment. In a thought experiment, we simply imagine. We imagine what might be true. And of course, these men who conduct these thought experiments are scientists. These aren't just any random imaginings. These are an intelligent, scientific contemplation or speculation about how the world works in a sphere that we are not able to observe. And so Albert Einstein worked through these thought experiments to try and solve some of the problems that arose as scientists moved to the microscopic level, studying the natural world. And Albert Einstein argued that Newtonian physics is not an accurate explanation of how things work. Albert Einstein argued that the Copernican model of the universe is not necessarily true, but that the ancient Aristotelian model is equally acceptable. Albert Einstein unraveled 300 years of so-called scientific development that had to be done because the Newtonian physics simply didn't explain what was now being observed. Albert Einstein published a great book, and it's a book that I recommend you get a copy of and read. You can get a free copy on archive.org. The title of the book is The Evolution of Physics. The Evolution of Physics. And it's by Albert Einstein. It's a simple, easy to read, short book that explains the history and development of physics and the principles of his teachings that became so important in modern physics, the theory of relativity and so on. But scientists in the 20th century realized that Newtonian physics were actually not true, even though every school student since the 1700s had been taught that they were true. And to this day, students in modern high schools are taught the principles of Newtonian physics as if they are absolutely true and proven through scientific experimentation, which is false. They are taught that the ancient philosophers were ignorant. They're taught that Christians in the past were ignorant and superstitious, and that scientists like Sir Isaac Newton followed the evidence and revealed the truth and saved mankind from the superstitious, ignorant, false teaching of the ancient philosophers and Christians, which is now known to be false. The topic of the talk again is whether atoms really exist. Of course, no one has ever observed an atom. The atomic theory is the result of 20th century thought experiments. The atomic model, with its protons and neutrons and cloud of electrons, all of this is theoretical. All of this is simply a model that's proposed as a way of understanding what appears to be happening when scientists observe the natural world at a microscopic level. The scientists don't know these things to be true any more than Isaac Newton knew his principles to be true. The scientists believe that their experiments prove that their models are true in the same way that Galileo believed the evidence proved his model to be true, and that Newton believed his investigations to prove his principles to be true. But there is no demonstrative evidence for these models or theories any more than there was demonstrative evidence for Galileo's model. There was no demonstrative evidence for Newton's principles. And there's no demonstrative evidence for these subjects we talk about in modern chemistry classes: atoms, molecules, protons, neutrons, electrons. There's no demonstrative evidence that these things actually exist. They are simply explanations or models that can be imagined that appear to explain what scientists see in their observations of things that they can't actually observe clearly. And so when I ask whether atoms really exist, it's not a silly question, not a contentious question. It's a question that needs to be taken seriously, because the science has been wrong on the grand scale many times. And this theory of the existence of atoms is not some innocent new idea based on the evidence. This is an ancient idea that has significant philosophical consequences. Children today walk around and talk about atoms and molecules, protons, electrons, as if they've seen these things, as if these things are as evident to their senses as rocks and sticks in the backyard. They talk about atoms and molecules. But there's no demonstration of these things. And some will say, well, what about the atomic bomb? Doesn't the atomic bomb prove that atoms exist? No, it doesn't prove it at all. The atomic bomb shows us that models and theories that modern chemists and physicists and scientists of other branches have developed can lead to the successful creation of a bomb that can kill entire cities of people, but it doesn't prove that the model that they propose is actually real or accurately describes what actually exists. Just because it works doesn't mean that it's true. That's a fallacy. That's the post hoc fallacy. It's like if I say that when I wear red shoes, the ice cream truck comes, and so I put on red shoes and the ice cream truck comes, and everybody says, oh my goodness, this theory is actually true. No, it's coincidental. It's not demonstrative. These successful predictions, successful achievements, like putting an astronaut on the moon, they show that the models are helpful, but they don't demonstrate that the models are necessarily true. Because for every success in modern science, we ignore many failures. And the failures suggest to us that the models aren't so reliable, that things aren't so simple. The failures of the scientists are just as important as the successes. But science is often allowed to get off the hook by people who are eager to embrace the models for other reasons, for philosophical reasons, for religious reasons, for moral reasons, for financial reasons. Many people are eager to embrace the models and are willing to overlook evidence that suggests that they're not true, because they're so eager for them to be true. for other reasons. If you can find an honest and accurate chemistry book that shows you a diagram of an atom, it will make it clear that this is not a real representation of anything that's ever been observed. It's simply a model. And this is no problem, because we do the same thing in geometry. In classical geometry, we draw a dot and we say this dot represents a point, but a point is not visible. So we just use this dot on the chalkboard as a symbol of a point, but a point by definition is invisible. We simply imagine a point. So we have no problem with using visible symbols and models. We do this in geometry. But we make it clear in geometry that this dot on the board isn't actually a point, but a point is invisible, really just a place. And this line that's drawn on the board in geometry is not actually what a line in geometry is, because in geometry, by definition, a line is a length that has no breadth, and therefore it would be invisible. It's simply the extension of a point in space. So we understand the need for sensible models, but we also make it clear that these are models, and the real things don't exist as they appear in the models. But modern science doesn't do this. They don't exercise this same caution, but they present these images to the children as if someone was looking at an atom and drawing what he saw. And no such thing has ever been done. And this is the problem with modern science. And so I'd like to recommend to you that book by Einstein, and I'd like to repeat the question: do atoms really exist? And what I'd like to challenge you to do is provide me, if you know of any, with demonstrative scientific evidence that atoms actually exist, or provide me with arguments why you believe it's impossible for atoms to exist. And we'll investigate this question together, but I trust that at this point in the talk you realize that this is a serious question that has important consequences in a number of different areas of life. And I don't ask it to be contentious. I don't ask it to be a smart aleck or just to get people riled up. It's a serious question. And while I expect, as you'll see in comments, I expect that the scoffers who have memorized all of the lines of their modern science textbooks will offer their criticism, but what they will never offer is evidence. And if anyone should be interested in evidence, it should be people who are serious about science. God bless.